Hi folks, we're going to take a look at page 432, number 10. So I've drawn the diagram here, and this is the Peace Tower in Ottawa. And they give us all these triangles with the measurements that I've already put on. Okay, so here you notice these right angle triangles indicate that this is a 3D diagram. So here's the Peace Tower, and here are two locations on the ground, and we have some information about this triangle here, which lies on the ground, and this triangle here, which is going up towards the top of the tower. All right, so what we're looking for is h, the height of the tower. And in terms of the information we have regarding h, well, we look at this right angle triangle here, we know an angle in that triangle. Okay, but that's not enough information to determine, to solve the triangle, so we're going to need some other piece of information. So, as we often do, we look to see, is there a relationship between this right angle triangle and the triangle for which we know lots of information, and it's this side length here. All right, so let's give this side length here, and so if we find this side length along with this angle, we'll be able to find the height. So that's a strategy. So now let's work with this triangle on the ground, and we have lots of information. All right. Now, I do know an angle opposite side pair because I know that this side length is 50. And while I'm not given this angle, it's pretty easy to determine because I know the other two angles. So here we have 142 is the total here. So if we need to get to 180, this is going to be 38 degrees. And because I have this side opposite angle pair, I can use sine law. So let's do that here. So I'm looking for z, so I'm going to do z divided by the sine of its opposite angle, 82 degrees, is equal to 50 over the sine of its opposite angle, which is 38. And now I can just solve for z very easily. So that's 50 sine 82 over sine 38. And so let's get our calculator and do that. 50 times sine 82 divided by sine 38, and we get 80.42. All right, and so now that I have this side length here and I have the angle, I can work with the right angle triangle to find h. So I'm looking for the opposite, and I know the adjacent, so I'm going to use tangent. So tangent of 43 degrees is equal to the opposite, which is h, the thing I'm looking for, divided by the adjacent, which is the thing I just found. So 80.42. And again, that's nice and easy. Just multiply the 80.42 to the other side. Sorry, that's 43 degrees. And now, in fact, I already had that in my calculator. So just multiply that to tan 43. And we have, well, looks like that'll even to do decimal places, it rounds up to 75 meters. So h is 75 meters. All right, so just to do a quick recap here, step number one is to correctly label the diagram. So just to make sure you know how to do this, when they say angle x, a, y, okay, the way you do this is you start at x to a to y, and it's the angle which forms between those two lines. So in other words, it's going to be the angle at the point that's in the middle, just in case you weren't sure how to do that. So once you labeled your diagram, you realize that the triangle you needed to solve for h did not have enough information. So you looked for something that was in common with another triangle, which was this side length z, in order to determine that first. Okay, that's it for this one.